This is for Year 12 methods. It comes out of Chapter 6, it's Exam Focus 35, which is a 2006 VCA Exam 2 question, therefore I can use my calculator. Consider the function which goes from 0 to 2 pi of 2 sine of x, and it's drawn for us there. Has a period of 2 pi, has a maximum of 2, minimum of -2. The graph is shown and two tangents are drawn at point A and point B. Find the derivative, or the derivative should be 2 cos of x, and find the maximum and minimum values of the modulus. So just to double check that, I have 2 sine of x I selected 2D, calculate derivative with respect to x. That gives me an answer of, in radians, an answer of 2 cos of x. And if I was looking for the modulus of cos of x, and I wanted to graph it from 0 to 2 pi, take it, drag and drop, I'm going to have a minimum of 0 and a maximum of 2. However, the derivative does not exist at the sharp joints, so therefore I'm going to have, so the minimum will equal 0 and the maximum will equal 2, because I'm not taking the derivative of the modulus of 2 sine of x, because that would mean that on the sharp joints the derivative wouldn't exist. I'm taking the derivative first, so the derivative gives me this. But when I'm looking for the modulus of 2 cos of x, that will give me a 0 and equaling 0 as a minimum and 2 as the maximum. Okay, looking at part B, the gradient to the curve with the equation y equals f of x, so therefore the gradient to the curve when the equation is y equals 2 sine of x, well, the gradient's going to be, if I take the derivative, dy dx, which will be 2 cos of x, at x equals pi on 3, is going to be 2 cos pi on 3, and cos of pi on 3 is a half. No, it's a half. Therefore, I'm going to get an answer of 1. So I've got an answer of 1. Therefore, at pi on 3, I'd expect the gradient to be 1. So at that point there, pi on 3. Find the other value. Well, the other value is going to be over here, and because of symmetry, I think it's going to be pi on 3 back from there. So my guess is 5 pi on 3. But what I need to do is I need to set the derivative, which is 2 cos of x, equal to 1, given x goes from 0 to 2 pi. I know one of the answers is pi on 3. I'm going to look for the other answer. So I'm going to have 2 cos of x equal to 1, given x goes from 2 pi, and I select interactive advanced solve, select interactive advanced solve for x, okay, and I get pi on 3, the answer that I knew, and 5 pi on 3, the answer that I predicted. Therefore, the other answer is 5 pi on 3. Okay, find the equation of the tangent of the curve at x equals pi on 3. So here, I know that it's at pi on 3, and if I sum x into the equation here, given x equals pi on 3, I get an answer of root 3. So that's root 3. So I know the gradient is equal to 1, and I know there's a point pi on 3 and root 3. Therefore I can use y minus y1, which is root 3, equals m, which is 1, times x minus x1, which is pi on 3. So y is going to equal x minus pi on 3 plus root 3 is the equation of the tangent. Part 3, find the axial intercepts of the tangent found. Okay, the axial intercepts. When x equals 0, so the y-intercept will be at 0 and minus pi on 3 plus root 3, and the x-intercept, since it has a gradient of 0, will be pi on 3 minus root 3 and 0. Part C. The two tangents to the curve at points A and B have a gradient of 1. Therefore, point A is on this first tangent. I've already worked out the equation of that tangent, and I know from the previous bit this is the y-intercept and that's the x-intercept. A translation of m units in the positive x direction takes the tangent A to tangent B. Find the value of m. Okay, if I consider this coordinate here, which is pi on 3 minus root 3, being moved to that coordinate there. So if I could find the x coordinate of this other tangent, then I should be able to find that distance m. So for the other tangent, I know that the gradient is equal to 1, and it has a point which is at 5 pi on 3 and negative 1, negative root 3. Just double check that. If that is 5 pi on 3, now through symmetry it should be minus root 3, and it is minus root 3. So I know the equation of that second tangent will be y minus y1, which is minus root 3, equals x with m, which is 1, x minus 5 pi on 3. And that should give me an equation which is y equals x minus 5 pi on 3 minus root 3. So it's going to have an x-intercept when y equals 0 of x equaling 5 pi on 3 plus root 3. Now, to know this distance m will be this 5 pi on 3 plus root 3 minus this pi on 3 minus root 3. It's going to be 5 pi on 3 plus root 3 minus pi on 3 plus root 3 to root 3 plus 4 pi on 3 is going to be the distance of m. And lucky last part, D. Let h be the function of all real numbers of h of x equals 2 pi to sine the modulus of sine. Okay, so h is going to be that's what up to pi would be. But instead of it being down here, that's going to get reflected up to 2 pi. That's going to go up to 3 pi, etc, etc, etc. Where is it going to be 1? Well, the sine of x equaling a half is pi on 6. So one answer will be pi on 6. You can have another answer here which is going to be 5 pi on 6, And then I'm going to have another answer here which is 7 pi on 6. Another answer here which is 11 pi on 6. Another answer here which is 13 pi on 6. 17 pi on 6. So it's really every pi minus pi on 6 or plus pi on 6. Every pi minus pi on 6 plus pi on 6. So my answers for x are going to be n pi plus or minus pi on 6. Now how would that look if I did it the other way? So I've got the sine of x equaling pi on 6, or, 2 sine of x equals 1. So that's either going to be 2 sine of x equals 1, therefore sine of x equals a half when x is positive, or negative 2 sine of x equals 1, sine of x equals negative a half when x is negative. Therefore, I'm looking for all stations to Coburg. I'm looking for when it's positive and when it's negative. I'm looking for all of the 0 and 2 pi plus or minus pi on 6 and pi plus or minus pi on 6. Therefore, I'm going to have this rule here.